Okay, so you guys open up the HR diagram lab and you should get something that looks like this. In last class, we went over the color of the sparklers. We went over the colors of the stars, what's hottest, what's coldest. We started the math part. If I did not finish that, I thought I finished it in this class, but if not, I'm not going to go over it again. What I did is right after class, I made a video, much like the video I'm making now, on how to do the math to solve for the questions for number 3. So what I want to focus on is questions part 2, which is this Hertzsprung-Russell diagram. Now, when you guys look at this diagram, you see something a little different. You probably see something that looks like you guys probably see a chart that looks like this, correct? Please nod heads. Okay, good. I had to update that because there were a couple of measurements on there that were incorrect. Most specifically, and I wrote them up on the board, Lewitton 726b should read 1.25 times 10 to the negative third power. I think it says 10 to the negative 5 power, and it doesn't chart right. And Sirius B, that is 2.6 times 10 to the negative 2. I think that one also said 10 to the negative 5, and it won't make sense. So how do you do this? So if everybody, and we can do this together. So everybody needs to be on the same page. Get to this lab, go down to this chart right here. And this is another one of those, I know you guys love Google Draw, but click on this where it says HR Russell diagram. And this is where I suggest if your trackpad's not working, use a mouse. But click on the image and then you hit edit. All right. And now you have the diagram to work with. Honestly, here's a piece of advice for you. It's going to be kind of irritating to go from the diagram, you have to hit save and close, and then go back and look at the chart. So what I suggest doing is just opening this lab up twice. You can open this lab up twice. Don't open it here, that's my stuff. But open the lab up twice. That way you can have the chart in one tab. There you go. So you can have the chart in one tab and then you can be working on the edit in the other tab. Just works a lot better. So if you click on this and you hit edit, and we go back and we look, okay, the sun, it says the temperature of the sun is 5,840 degrees. I'm sorry, I said that wrong. Error. 5,840 Kelvin. There's no degrees in Kelvin. That's its temperature. Its luminosity is 1. And the reason why the sun is 1 is because we're going to compare all other stars to the sun. Okay? So if you see something like this right here, it says 6.93 for luminosity. That means that Procyon is 6.9 times brighter than our sun is. All right, so what do we do here? So we look and see the temperature of the sun was 5,840. If we look at our chart, and you can resize this if you want, make it larger so it's a little bit more visible. Just make sure you keep those dots exposed. There's the temperatures are across the bottom. So there's your temperatures, all right? Notice it goes from 30,000 down to 3,000. So it's going down. The temperature is going down. The coolest temperatures, remember, are red. The hottest temperatures are blue. So we're looking at the surfaces of the sun. Just so you guys know, these letters, those are classification systems of stars. All right? There's no real meaning to the letters that I've been able to find when she classified the stars. Why did she choose that letter? I don't know. As best I could tell you, it has something to do with where the electrons are at in the atom. So as far as you guys are concerned, you don't need to know. If I don't know it, you guys don't need to know it. Just know this. An M-class star, that's its stellar classification, means that the temperature of its surface makes it red in color. So M-class stars are red. K-class stars are orange. G-class stars are yellow. A-class stars, we're getting into F and A, are kind of getting more into kind of greenish and white. B-class stars are blue. And O, it's hard to see, but there's an O there. The O-class stars are dark blue, in some cases purple in color. Okay, so the sun being 5,180, you'll notice that it goes 3,000. This tick mark means 4,000, 5,000, and then there's 6,000. So 5,000 is going to be about right here. All right, right next to the 6,000. 5,800 is about 6,000. It's one luminosity, so there's the one luminosity is going to be right there. That means they're going to meet about right here. So you're going to want to put a little dot right there. So what color is it? Yellow, thank you. It should be yellow. So what you want to do is you want to click on the yellow dot. And this is the part that everybody hates and is frustrated. Like Mr. Lee, I hate it when you do these Google Draw things, because if you try to go to move it, then it's just going to make a big oval and it screws it up. So there's a couple of ways you do this. If you click on it and hold down, you can drag that little dot to where you want it to. Or if your trackpad's not working, you can just use the arrows on your keyboard and bring it. In fact, it's a little simple. You can bring it to about where it's at. That's about 5,800. Bring it up to where it's about 1. And then you can drop that right where it's supposed to be. Now, notice that when I did that, my star disappeared. That's because I made a mistake. All right? And this is where I need everybody to fix this mistake. Click on the graph. Yep, right, you got it. Hit order. So right click on the graph. Order. Send to back. Let me repeat that. Right click. Order. Send to back. Now you notice that my little star actually appeared in the right place. Are we good so far? Okay. So let's look at a different star. Let's do Barnard star right there. So Barnard star is 2,800. All right, so its temperature is 2,800. So it's actually kind of a cool star. It's going to be down here in the M class of stars. 2,800 is going to be down here in the red areas. All right, but its brightness is 4 times 10 to the negative 3. So this is the x-axis. I'm sorry, the y-axis is a little weird. It goes by powers of 10. Starts off here 1, that's the brightness of the sun. Then we have 10 times brighter than the sun. This says 10 to the 2. That means 100. Okay? 10 times 2, so this would be like 100. 10 to the 3 would be 1,000. 10 to the 4 would be 10,000. 10 to the 5 would be 100,000. And 10 to the 6 would be 1,000,000 times brighter. Okay? If we look here, that's negative 1, that would be like 0.1. Negative 2, 0.01. Negative 3 would be 0.001. All right? So Barnard star is 4 times 10 to the negative 3. I wouldn't really worry about the 4. I would just look for that 10 to the negative 3 right here. All right? I'm going to go back to my graph. All right. I'm going to grab one of these little red dots because if it's 2,800, it's going to be right here. So I'm going to grab that red dot and I'm going to drag it over to about right here. And we said 10 to the negative 3. It's about right here. You should be able to drag it to right there, which means that's where the Barnard star should be. It's a small, not very bright star. All right. At this point, we should be able to hit. You're going to do that for all of these. And then you guys are going to, you should do that. So you should have a dot for all of these on there, okay? Hint. All the dots should be on a color. You're not going to have a dot right here in the white area. If you have a dot in the white area, that's where you raise your hand and say, Mr. Lee, I think something's going wrong. That's what happens on your guys where it says Luden and Sirius. They appear on the wrong colors. Sciences, Mr. Lee? Yeah. Sure thing. Whereas I'm still recording, I'm going to point and say go to counseling. Okay. So if you had those numbers that were given to you, they're not going to be in the colored areas, and so they're going to be in the wrong place. So when I go to grade this, I'm going to be looking to see that they're in the colored areas. Okay, there's some questions you guys are going to answer from those. Excuse me. After you get done answering those questions, you're going to see here's what the chart should look like. This is a lot of known stars already plotted. Notice that most of the stars occur along this line. I talked about that when we did notes the other day. That's called the main sequence of stars. These right here are called the giants. These are the supergiants. And then over here we have the white dwarfs. Some more questions based on that graph. Then we get to part 4. It says Star in the Box Lab. You're going to click on the picture, and it's going to bring up a link. You're going to open that link. You're going to get something that looks like this. Switch it over to Advanced. Open the lid. And here it gives you the star, our sun, its temperature and its luminosity on the main sequence of stars, right? If we hit play, what you're going to see is there's our sun. As the sun, in about 5 billion years from now, as the core starts to collapse and pushes out the hydrogen, this is how big our star gets. From here, it goes, it sheds it off, and it should have a little small dot. It's too small to see down here in the white dwarf area. All right. Now, when we do this, when we play this, you can see how it's going. You can see the size of it. You can also see how the temperature is changing. You can see how the luminosity is changing. You can see what stage it's in. It starts off in the main sequence, and then it goes to the blue giant group, or the red giant group. And we can see if its mass changes. But all that information is given right here in the data table. So if you click data table, all that data is given. And if you look a little bit lower, it's going to be asking you, it's going to be showing you where that data is. Okay, so that's where you're going to be able to find it. All right. So just follow the instructions. You should be able to do that, no problem. To the person that just walked in, I'm recording this for the people who are testing today, so I won't be using your name. Just realize that the camera's on me, not you, so forth and so on. So you guys are going to play with that star in the box activity. You're going to be changing the mass of the star to maybe see what happens if it's a 30 mass star. What's it going to be like? Well, that's our sun. That's how big a 30 mass star would look when it's on the main sequence, and what color it would be. And then you can press and see what's going to happen to its life. So it's a little kind of game thing that you're sort of playing with. And then from there, the last part of the lab, after the last test, I told you guys, I need you to give me 2 stars. I want you guys to give me 2 stars. Why did I tell you to give me 2 stars? Well, if you chose 2 stars, maybe one of them is really obscure and there's not a lot of information on it. Go with the other star. All right? Because this is going to we're going to be working on this lab today. You're probably going to be working on this lab next class as well. And then we're going to be working on the STAR project where you and a partner or partners are going to be working together. And you guys will be choosing the star and probably the one that has the most available known information about it. So this lab, however, means you're going to take your star that you gave me in that list the other day, and you're going to give me a little bit more information. And then you're going to plot your star on this Hertzsprung-Russell diagram graph. Then you're going to be filling out the data from the box lab, the star in a box. You're going to put a snip of that HR diagram and put it in here from the box lab, the star in a box. And then you're going to answer a few more questions on it. So that is, for the most part, that is it. I'm going to wish you guys good luck.